Okay, welcome everybody to our last panel discussion of the day here at the Night Studio. I hope you've all had a magnificent day. I hope you've had the opportunity to have lots of great conversations with your peers and your colleagues, and I hope you've had the chance to absorb lots of new knowledge and understanding. To wind down for the day, we decided to go with the easy to understand topic of Web3 and blockchain. You'll be glad to know. So, hosting this session, we have Ben-Ari, the highly esteemed, I think it's fair to say, founder and CEO of Applied Blockchain. And Adi, I'll leave it to you to introduce your guests. So, Adi, over to you.
Yep. Thank you very much. So, last session of the day, we're not going to wind down, we're going to wind up. Hopefully, we're going to make this an exciting panel for you. So, my name's Adi Ben-Ari. I'm the founder and CEO of a company called Applied Blockchain. We build blockchain solutions. We've been doing this since 2015, and we're doing a lot of work in supply chain. Looking back to the previous panel, our biggest client was represented there, which is Shell. We've done work with them on supply chain and on trading as well. Just a quick, before we get to the panel themselves, just a quick view on blockchain itself. So the way we look at it is blockchain is a network of computers, and the reason to set up this network of computers is to create more trust. Through this group that hosts this network, we no longer have to trust one party with their data and their information and their control of that data. We effectively delegate that trust to the entire group, or the majority of the group. And that means that we can have more trust in this data. That comes with a cost, because you now have to pay for all this group and this data and all of that replication somehow. But on the other hand, you get stronger authentication of the data and stronger security around it. And that's quite important in a sustainability context, and also thinking back to the last panel in terms of federation. Sustainability goes across supply chains. That's a federated group. When you've got that kind of group, they've each got their own data sets. How do you trust the data coming across that group? Do you trust it when it's aggregated with one party and they're presenting it to you? Or wouldn't it be better if each party was responsible for their data and you could trust the set across the group? So that's a little bit of an intro. One other thing to say just before we start is blockchain itself is obviously very controversial, has its ups and downs. We have the crypto world, we have the enterprise world, and so on. But also in terms of sustainability, we have Bitcoin itself, which was the original blockchain, which uses a lot of energy. Right? In order for Bitcoin to be up and running and to secure itself, there is a huge amount of energy consumption that goes with it. So it's not a very sustainable solution. But that's not to say that blockchain overall isn't sustainable. There are other blockchains which solve that problem and are at completely the other extreme of the spectrum. So on that note, I'd like to introduce Eric. Or do you want to introduce yourself?
Thanks, Adi. So I'm Eric Wragge, working at Algorand, which solves that problem, Adi. Thank you very much. Perfect. So I was in finance for many years in London. I'm from Canada originally, but 20 years there, and I guess to Adi's point, very much a case of data within four walls. You let some data in, you process it, you add to it, and then you release what you want to. And I think during the latter part of my 20-year career at JP Morgan, I became very interested with this idea of systems that could be trusted, that many people could plug into, and this idea of having sort of data has to be all held by one person in one place and controlled, making a more accessible system became very interesting to me. And I think as a sustainability, it's especially important. So I think it feels to me like every panel I went to today, it felt like there was a big company or there was a big person who was saying, but we have a portal, we have a solution. All you have to do is log into our system, we'll capture everything, we'll process it for you, and then we'll give you the result. And everybody's got their own sustainability survey, and we're buying something from you, so you need to fill out our survey and tell us how much carbon you use to produce that item. So I think in contexts like that, where you're dealing with, in the case there was a gentleman before from Marks and Spencer's who said they have 30,000 suppliers. In situations like that, where you've got this incredibly complicated web in the world, I think blockchain and Web3 can be incredibly powerful. So that's my brief introduction. Working at the Algorand Foundation in charge of business development. I guess the 2 seconds on Algorand is that it's a layer 1 blockchain that uses about as much electricity as a Tesla car charger, and we offset that electricity. When we talk about that, it's all the metrics are up in real time. I checked, there's 1,177 computers all around the world run by different people right now that are confirming all of the transactions through that chain, of which there's been hundreds of millions, confirming that all of those are true, valid, reliable, and will be recorded forever immutably. So that's my intro.
Thank you. I'll go. My name is Umberto Cuchi. I'm Business Development Manager at Circularise. I don't know if you know or if you're familiar with Circularise. It's a blockchain-based transparency and traceability platform. So we're a software company focusing on end-to-end supply chain traceability, creating digital product passport for products. So there's a lot, of course, regulation entering into this space, both at the European level, but as well as North America and Asian markets. And we create this, the first area, of course, that will be subject to this regulation will be batteries. So but you can think of airplanes, cars, television, and we trace materials from one end to the other of the supply chain. So at the digital level, powered by blockchain. So if you think of a battery, we go from the mines to the extracting the minerals, tracing everything up until the battery, the final thing. So that's what we do in a nutshell. Looking forward to this panel. Thanks for the introduction.
Okay, very good. Thank you very much, both of you. Umberto, just to come back to you, what would you say is different about your platform with the fact that it uses blockchain? So what difference does that make?
No, of course, that's thanks for the question. So I think that Web3 and blockchain technology can really help in bringing more transparency and traceability, especially not only in the traceability of materials, but as well in the global carbon credit market. Does this by probably addressing the challenges in a very nice way. So ensuring that, for example, double spending, double accounting of carbon credit doesn't take place, and ensuring that it takes place the data integrity, that's a fundamental aspect, but as well ensuring that proof of ownership and verifiable aspect. So as I was mentioning at Circularise, we are a traceability and transparency platform. So we enable companies to share, but as well verify information about materials and products without also compromising the aspect of privacy of certain data sets. So we manage different data points from one end or the other of the supply chain powered to blockchain technology. And I feel like we're able to take advantage of some key aspects of Web3 and blockchain technology. So, of course, you know better than me, the immutable ledger, so taking advantage of that timestamp transaction, not modifiable, not deletable, getting over that risk of fraud and manipulation, taking advantage of the concept of smart contracts, so the ability to write agreements already into the code, and then whenever, for example, it triggers or some threshold or reach in terms of carbon, it can be directly sent or receive the carbon credits, and ensuring that concept of proof of ownership as well. So having a clear overview on the chain of custody, so knowing who owned what and which stage, avoiding that, what we mentioned before, that double accounting, double spending of, for example, carbon credits, or it could be tracing materials. You were asking before on also how we differentiate ourselves using blockchain. We're big believers in public blockchains compared maybe to private ones. Not to say something too controversial. We feel like
that can be another panel.
We feel like our vision is that at least in private blockchain, you need to put maybe a higher degree of trust on the nodes that took place before, or whoever is running the private blockchain, while in our vision, public blockchain, you have not that urge to verify. It's more easy to verify the correctness of the data and its access to.
Yeah, I mean, it's open for anybody.
Exactly, accessible to anyone to verify a transaction and who on what and at which precise moment. So, bottom line, we feel like that, Web3 and blockchain technology can really play a big role in bringing more transparency and traceability to the global carbon credit market, as well as traceability of materials as a whole. So That's
what are the main industries that you're seeing this in? What are you seeing
it's mainly regulation driven. So the European Union, but as well as we mentioned before, North America as well as the Asian markets are tackling a certain industry. The biggest one as of now is batteries, mainly due to the fact that 2027 in the European Union, any battery will be sold, traded, or utilized above a certain voltage, about 2 kilowatts per hour. It will require to have a battery passport. So that's where there's a lot of movement happening as of now. But then automotive is another one, electronics, textile, plastic and chemicals. So there's a lot of movement in different industries, and of course regulations are helping to move faster toward digital traceability powered by blockchain.
Yeah, okay, interesting. A couple of other sort of anecdotal things to add. Last night, Apple had their event with the iPhone, and I keep watching these things. And I don't know if any of you saw it, but almost the first hour of the event, rather than talking about the devices, they actually talked about their supply chain provenance and sustainability. And I think when you get a company like that putting this subject so much at the front and breaking down their supply chain and talking about their credentials, then I think you can just see this surfacing to the top of marketing, and therefore the importance and demand coming through for it. That's one point. The other thing I want to say, sort of more in relation to blockchain, is also in relation to AI. So one of the problems that we're going to have more and more with AI is really being able to trust the information that we receive, and knowing when it's generated, who it's generated by, whether it's real or not, and so on. And I think about blockchain and cryptography. Blockchain is a kind of a subset of cryptography as a counter to AI. And actually, these are two areas of computer science that are really developing in our time right now and kind of counter to each other and complement each other. So whereas in AI, everything is probabilistic, and so you don't have anything exact and you don't know exactly what's real, with cryptography, and blockchain is a part of that, it's actually absolute. So things are digitally signed. You can check that something's come from origin. You can see absolutely that it hasn't changed. So this kind of confidence that you can have against the data is I think, going to be more and more important and significant in different areas, including in supply chains and sustainability. Thoughts or other ideas?
My thoughts, I mean, the simple example, I think, is like imagine a world where there's a bunch of companies, they're all big companies, and we're trying to work out this as a world. We know how much carbon budget we have before we're going to hit this 1.5 degrees and have these catastrophic problems. And so globally, you have leaders saying, we need to limit the carbon, we need to do it down, and so on. So then, I guess, in the world we're in now, you have all of these big companies, they put out sustainability reports, and they say, this is how much carbon we used. And if it's a company like Shell, who spends a ton of time on their disclosures and sustainability, they're digging up all this carbon, and then they're passing it on to their customers, and they say, okay, well, we don't actually use so much because we power some of our diggers and pipelines and things, and then we pass on X gigatons of carbon to all of our customers. So they're the ones, that's kind of their carbon to account for. Now, I guess you flow that all the way through the system until you end up with maybe a retail customer who puts some petrol in their car and drives somewhere, who uses the carbon at the end. From a pure mathematical accounting point of view, you should say 1 ton of carbon that comes out of the ground is ultimately going to be 1 ton of carbon in the sky. And so for all those steps along the supply chain, who burned how much of that petrol before the customer burned what was left over at the end? And I think that's really where, if we look at it now, what you have is you have a bunch of people self-reporting on how much they use. And as we can see here, there's a ton of frustration as well, because the people who are self-reporting, even if they want to be accurate, it's very difficult for them to do that, because they're buying stuff from 10,000 different companies. They're sending questionnaires to 10,000 companies, and God knows what answers they get back. All of these 10,000 companies want to sell them things. So all of the 10,000 companies have an interest to say, oh, actually, I'm like super sustainable. I'm not using so much carbon, and so on. And so the whole thing just gets incredibly messy. And so probably what happens is we have 1 ton of carbon out of the ground, and if we add up all the disclosures along the way, maybe you have like 200 kilos of carbon that people claim they've kind of burned, but then we know there's no petrol left in the tank, and we know there's sort of a missing 800 along the way. So I think that's kind of where the blockchain stuff becomes super powerful, because you say, okay, look, like if there's 1 ton comes out, that's recorded on the chain. Shell says, okay, well, we actually used of that, we used this much to power our diggers and so on, so we'll put that into our reporting. Then they pass on those kind of that carbon liability or their carbon budget to the next customer. The customer uses the amount. All of those things kind of mathematically at the end need to equal the 1 ton that was pulled out of the ground. And I think that's where it becomes super powerful, because if you don't do something like that, you're going to need to, Google or Apple or somebody is going to need to have one database that every single person in the world logs into and says what they're burning, or you're going to have some system that kind of runs like the internet that kind of anybody, whoever they are, can plug into and access the data in that way. So if you want to go to the pump and you want to fill your car with petrol, that's cool, but there's going to be 2 data points are going to be assigned to you as a person at that point. One is how much cash left your bank account to pay for the petrol, and the second is how much carbon you put in your tank. Yeah. And I think that's where we need to evolve to.
Okay, interesting. I mean, another way of thinking about this is, and I've heard this throughout the day, this, as you said, this challenge of having to collect all this data, right? I listened to Bosch earlier, and it's also 30,000 plus suppliers, and how do you even get this information from them? And really the idea that all of this information has to be gathered by each of the parties in the supply chain on their own, going up their supply chain to find it. Whereas it's really a network. Right. And it's really each party can report what it's doing, and whoever's next in the chain can use that, right, reliably, because it's been reported. And that's a more efficient way of starting to tackle this, I think. Yeah.
And it's like, I mean, if we look at, I don't know, property in the UK, all the properties in the UK, they go into the land registry and there's a name beside each one of them. And you've got kind of one agency there that's recording it. Who's burning the carbon, or who's digging up the lithium, and from where? These things are not, there's no kind of central party that's doing this right now, which is why I think it's such a mess.
Okay, very good.
Brilliant. So we'd now like to open to questions. So for those online, again, we haven't got any questions come through yet, but if you would like to submit a question, then please do so through the chat window. Do we have any questions from the audience here today? Brilliant.
Yeah, Adi, you mentioned protecting against AI. I'd love you to expand on some sort of use cases for blockchain in that area.
I mean, we're just at the beginning, I think, with all of this, right? With AI and with blockchain, right? I mean, from my perspective, I've been in the blockchain space for 7 years now, and I think it's barely started, right? We've barely got going.
That makes you incredibly old in the space, that is.
Let's not go into that. And I think it's the same thing with AI. But one problem that we can already see with AI is just how easy it is to generate information and therefore to proliferate fake information. And you can just imagine, fake reports coming out, right? And how do you know what a company's really done, right? Somebody wants to put out some misinformation about a company. How does a consumer know, or even a journalist know what's real and what isn't? And there's a specific project which we've looked at a little bit, which we were discussing this morning, called WorldCoin, which was interestingly started by Sam Altman, who's also the founder of ChatGPT. And OpenAI, and the idea there is part of this, right? Is to try and counter what's potentially going to happen with AI with this kind of cryptographic backbone, where you can have certainty of where data's come from, where it's originated, or who it's been originated by. So you need, for that, you need identities, or even, it could still be anonymous players, but you need to know they're unique, or you need to know there's certain properties or attestations attached to them. So these two things, I think they will interplay, because I think there'll be demand for that, because, as I said, AI can get out of control in many ways, hopefully not too many, but in the area of misinformation, it can. And so I think we'll need to lean on a technology that can give us more certainty, which is cryptography and blockchain being part of that. Does that make sense? Yeah, okay.
Brilliant. Thank you, Adi. Any other questions from the room? Yes?
Hi, thank you. Very interesting. One of the things with blockchain is it's, well, there's very energy intensive, I think, when you have like a proof of work to validate the changes on the blockchain. I think it was Ethereum, perhaps, that moved to proof of stake, which is my understanding is where it's becomes who effectively owns the cryptocurrency or something like that. Is there a way to move more towards less carbon intensive or less energy intensive blockchains? And it seems like this is precedent being set there with Ethereum or whichever cryptocurrency it was. And
Yeah.
is this future? Is it possible to get to a much less energy intensive cryptocurrency or blockchain technologies?
Yeah, so I'll let you answer that in a minute. I'll just say, first of all, that there's a tension in the blockchain world between what we call decentralization, which is having different parties hosting these computers, and their incentives, right? And Bitcoin solves this beautifully by basically encouraging anybody to host one of these computers and the Bitcoin software, but disencouraging them from trying to have too many. And it does that by attaching an economic cost to running one of these things, and that's through energy consumption. Right? So you have this hashing algorithm, and you have to solve this problem, and that means you have to use a lot of electricity, and therefore that's going to cost you, and so you're not going to be able to fire up a large amount of these, and so you're not going to be able to take over the network, and therefore it stays secure. That's how Bitcoin solved it, which was great, except for the energy consumption. Ethereum started off that way and shifted to what we call proof of stake. That was proof of work. Proof of stake is basically where there's an underlying cryptocurrency, there's an underlying token, and parties that are hosting nodes or hosting these computers have to hold a certain amount of these tokens, and they can be penalized if they act maliciously by having their tokens taken away from them. And that's how you encourage them to secure the network. Ethereum moved to that and reduced its carbon footprint by 99%. So it's very effective, but none of these things are perfect. Bitcoin is decentralized in one sense, but also the mining is quite consolidated amongst a small number of companies. Ethereum is also largely decentralized, but a lot of the staking is actually held by, I think a third of the staking value is held through one organization, which now has a lot of power with that. So this is still being played out and experimented with, and so we don't really know what the ultimate answer is, but it's kind of being played out in real time with kind of the different forces at play. Is that fair?
Yeah, I think that's right at it. I mean, because broadly, yeah, there's kind of two big things. Algorand was proof of stake since day one, since it was invented by a professor at MIT. And then Ethereum, I think, yeah, made the switch. It was last year, right, that it switched over. And I think, thank goodness they did, because prior to that, they were burning energy equivalent to Argentina before that happened, which, in my opinion, is not a great thing to do. So I'm glad they switched over. And at this stage, I think pretty much everybody is using proof of stake, which is far more energy efficient. I mentioned in the case of Algorand, it's like, we have these, at the moment, 1,200 computers running all over the world and hundreds of millions of transactions going across it. It's like one Tesla charger. I think that's sustainable. Bitcoin, I think, is clearly not. But that's really the only one out of all of them, I think, that's burning energy on that scale.
You said it perfectly, so there's very little to add.
Okay, well, one more question, if I may. Just to wrap up with your final thoughts, what is your long-term view of the impact that Web3 and blockchain can have on sustainability in the supply chain?
If it's for me, I would say fully transparent and traceable supply chains. And you were mentioning how complicated, how many 2,000, 20,000 suppliers, but the goal is that one, to have fully transparent from one end to the other supply chains. That's the goal, that's the direction to take from my side.
Brilliant. Brilliant. Can we all put our hands together for our final panel discussion of the day? Thank you.
Thank you.
Thanks, everyone.
Thank you very much.